Today, we'll look into 3 examples that follows our previous class under linear algebra, episode 1. So, let's see the first example. We say let u be equals to -1. This is vector u. Is a vector. 3 of them are vector. Let vector u be equals to -3, 1, 2, vector v 4, 0 and -8, vector w 6, -1, -4. Find scalars. These are scalars now. C1, C2, C3, such that C1 multiplies u plus C2 multiplies v plus C3 multiplies w will give us 204 under vector. Remember that these are vectors of 3 on 3 space. So how can we solve this? This will take a lot of space, so let me divide it. Let me divide this board 3 times. So this is the question. I go up. Let me go up from here. So this is the question. Let's solve. Solution. From our previous class, we know what is a vector and we know what is a scalar. And this is a scalar multiplication, something to times. So we have that C1 u vector is equals to C1 minus 3, 1, 2. And C2 v, vector v, simply means C2 4, 0, -8. C3 w simply means C3 6, open bracket 6, -1, -4. So we multiply those things. We multiply them. C1 u is equals to -3 C1 comma, we have C1 comma, we have 2 C1. This is what we have. Then C2v, we have 4 C2 0 and we have -8 C2. On C3, that is C3w, we have 6 C3, 6 C3, comma, minus C3, minus 4 C3. We will not put 1 now. Minus C3 simply means minus 1 C3. So we have this. Then, coming back to the question, remember that this plus this plus this gives us this. So, I think I'm going to open this line from here so we can express this. So we have that, I think it will go like this. It will be better if we go like this. Okay, from here now. So we have that C1 u plus C2 v plus C3 w is equals to, let's see, it will enter, is equals to minus 3 C1 comma C1 2 C1 close plus open bracket 4 C2 0 minus 8c2 close plus we have 6c3 comma minus c3 minus 4c3. Now this plus this will give us 204. It will give us 204. Now we are now into addition of vectors. Remember what addition of vectors is? Take them according to their what? IJK that time. So we'll take this first one here plus first one here plus first one here equals to first one here under addition on vectors. So from here we are asked to find the scalar. So let's continue. So we are now solving with this. We now have that minus 3c1 plus 4c2 plus 6c3 is equals to 2. 3 minus 3c1 plus 4c2 plus 6c3 equals to 2. We call it equation 1. Come down, we have that c1 only plus 0, that is 0c2 is 0, plus, okay, not plus now, minus c3 will give us 0. We have 0 here. We call it equation 2. There is something I need you to understand in equation 2. Or let me put it now. Now this, or let me continue. Let's continue. When we reach that place, I'll put it. Now in 3, we have this 2c1 plus, okay, is minus 8c2 minus 4c3 will give us 4. We call it equation 3. And we have 3 equations. We are looking for now C1, C2, and C3. From equation 2, you will see that C1 is equals to C3. From equation 2, C1, if minus C3 crosses, changes that C1 is equals to what? C3. Let's continue with this down part. So now go up. Let me draw a line. So since this, let's call this, okay, let's not name them. Now we can now say substitute C1 equals to C3 and I, that is in 1. We should put this in 1. This means that anyone now, if we reach here, remove C3, represent it with what? C1. So from here now, we want to remove this C3 since C1 and C3 are equal. So we want to remove this C3 and put what? C1. Or even we can remove this C1 and put C3. But no problem, let's remove C3 and put C1. From here, we now have minus. From here, we now have minus 3C1 plus 4C2 plus 6C1 equals to 2. We solve. From here we have that 4C2, we take this one first, plus 6C1 minus 3C1 will give us 2. We collect like terms. So we now have that 4C2, this plus this we can give us plus 3C1 is equals to 2. Can we call this equation 4? Let's call this equation 4. Now let me solve another one here. We now say solve C1 again equals to C3 and 3. That is, anywhere we see C3, let's represent it with C1 in equation 3. So we move like this. We have 2C1 minus 8C2 minus 4. We now represent this C3 with C1 equals to 4. As we have this, we now say that we have 2 here, so we collect like terms. Now let's start. Okay, let's take this one here. We have 2C1. Let's put it like this so it will be more okay. So we now follow here 8C2. Can we say minus 4C1? This one is remaining plus 2C1. This is collection of like terms, which gives us what? 4. In this case now we have minus 8C2 minus 4 plus 2 will give us minus 2C1. Remember, this is C2, C2, C1 equals to 4. Equals to 4. Now let's call this equation Z. We have this. Now, watch from here. We have 3 equations before, but we have managed to get 2 equations, V and IV. We have 2 equations now with 2 unknown, C2, C1, C2, C1. So we are going to combine these 2 together to see what we are going to have for C2 and C1. So let's start from here. Let's start from C5. So from V, that is from here. Remember, we still have IV. So from here, we make this the subject formula. So gradually we have 2C1 is equals to 4 plus 8C2. We divide both sides by C1 and we divide both sides by minus 2. We have C1 is equals to minus 4 minus 8. Okay, let me not go like this. Let me go small. We divide both sides by minus 2. So we have minus 4 plus 8 C2 everything over 2. Now from here, we take our C1 to be equals to minus 4. Okay, now not minus 4 again now. Okay, let's say minus 4 minus 8 C2 all over 2. We now have that C1 is equals to, we divide. If we divide this by 2, we have minus 2 minus 4C2. Now we say input C1 equals to minus 2 minus 4C2 and IV. So we put this into this. This means that Any place we see C1, we should put -2 -4 C2. So any place we see C1 here, we put that. So we move 4 C2 plus 3 open bracket -2 -4 C2, which will now give us 2. We now open this bracket. We have 4C2 plus, okay, it's not no longer plus. 3 minus 2 will now give us -6. 3 minus this will now give us -12. C2 equals to 2. We collect like terms. If we collect like terms from here, we have that 4C2 minus 12C2 will give us 2. This -6 crosses, changes to +6. So from here, 4C2 minus 12C2 will give us -8C2, which will now give us 2 plus 6, which will give us 8 also. So from here, we can see that C2 is equals to -1. How do we get -1? Divide both sides by -8. We have -1 for C2. We should call here equation. We have 5 here, so let's call it 6. We have 6. So we now say substitute C2 as -1 and 6. Why are we putting it in 6? Because it is at this 6 we define our what? C1. We define our C1 to be -2 -4 C2. So we use -1 to represent minus, and we use -1 to represent C2 here. So we now have that C1 is equals to -2 -4 open bracket -1. So our C1 is equals to -2, 4 -4 times -1 will give us +4. So our C1 is now 2. Now recall that C1 is equals to C3. C1 is equals to C3. Therefore, C3 is equals to 2. Our scalar now is C1 equals to 2, C2 equals to -1, and C3 equals to 2. This is our answers. Now, if you want to check this is true, let's take it out if we are going to have 204. Use this. You say, remember they said C1 yo. So we are going to use 2 to multiply everything here. Let's say C, that is now C1 yo. Let me not write C1. Let us go straight. Let us go straight and write C1 yo now is equals to 2 times -3, give us -6. 2 times 1 is 2. 2 times 2 is 4. Then C2V will now give us -1 times 4, -4. -1 times 0 is 0. -1 times -8 is +8. Now we have C3W. C3W will give us 2 times 6 is 12. -1, 2 times -1, -2. 2 times -4 will give us -8. We add everything. -6 plus -4 will give us -10. -10 plus 12 will give us only 2. 2 plus 0 is 2. 2 minus 2 will give us 0. 4 plus, there is comma here, so they are not the same. You can see here is obvious. 8 minus 8 is 0. 4 plus that 0, 4. So you can see we have this, which is this. So this is how to find this scalar. Let's go to second example. The second example says, show that there is no scalar C1, C2, C3 such that C1, C2, C3 is equals to this. This question means that we show there is no scalar here. There is no scalar here that will multiply these things to give us this. How do we show it? The same process we take in our example 1. The same process. We open this bracket. We now have minus 2C1 minus 2C1 9C1 6C1. If we open this bracket plus, we have minus, that if you open this bracket, we have, let me still put plus here. We now have minus 3C2 plus 2C2 plus C2. Due to here is 1. We close. Plus C3 plus, 7C3 and 5C3 will give us 0, 5, 4. We add one after the other. Minus 2C1 minus 3C, minus 3C2 plus C3 is equals to 0. We have this 9C1. Okay, we call this one equation 1. So we have 9C1 plus 2C2 plus 7C3 equals to 5. We call it equation 2. The next one, 6C1 plus C2 plus 5C3, we call it 4, equals to 4. We call it equation 3. Now we have 3 equations. Now from I, I want to make C3 the subject formula here. So from Y, we have C3 equals to, this one crosses positive, 2C1, this one crosses positive, plus 3C2. So let me name this one equation 4. Then I can now say that is substitute 2C1 plus 3C2 for C3 and 2. Let's start in 2. This means any place we see C3, we should put this under equation 2. So we have here 9C1 plus 2C2 plus 7, open bracket. We want to put this now. 2C1 plus 3C2 close equals to 5. We now have that 9C1 plus 2C2 plus 14C1, that is 7 times 2, 14. 7 times 3, we now have 21C2 equals to 5. We collect like terms here. We go like this. 9C1 plus 14C1 will give us 23C1. 2C2 plus 21C2 will also give us 23C2. and let's say plus 23C2, which will give us 5. We call this equation 5. Now we say again, sub 2C1 plus 3C2, that is this, for C3 in equation 3. You know what we did here? We put this equation 2 into, we put this into equation 2 to get this equation 5. Now we are trying to put this in equation 3 and see what we're going to have. So we have 6 C1 plus C2 plus 5 open bracket 2C1 plus 3C2 close equals to 4. We open this bracket. For us to open this bracket, we still have 6C1. We still have 6C1 plus C2 plus 5 plus, not plus 5. 5 times 2, we have 10C1. 5 times 3, we have 15C2 equals to 4. We collect items. 6C1 plus 10C1 will give us 16C1. C1 plus this, that is C2, C2, that is 1C2 plus 15C2 will equally give us 16C2, which is equals to 4. We call it equation 6. Now, we have equation 5 and equation 6. Let's put them together. Now, having this equation 5 here and this equation 6, let's put them together to see what we have. Starting from equation 1, we have 23C1 plus 23C2 is equals to 5. We put this 16C1 plus 16C2 is equals to 4. So we have this. And this is like now a simultaneous equation. It's a simultaneous equation like this now. That is a simultaneous equation of 2 variables. Before it's under 3 variables. So, as we have this, how do we solve this? We can say let's go into elimination method. Can work here. Or substitution method can work here. We have big numbers. Like here now we have 4. 4 can divide through. I didn't say this coming. We can divide here by 4 to reduce this number. We have 16, 16, 4. So we can divide this IV by 4 to reduce this number. If 4 divides 16, we have 4C1 plus 4C2 equals to 1. So let's take this as our IV. We call this our VI, So here will now be 4C1 plus 4C2 equals to 1. So through elimination method, that is, let's multiply equation 1 by equation 2. But there is something I need you to see inside this place. You can see that both C1 and C2 they have coefficient of 23, 23. Here, both C1 and C2 have coefficient of 4 and what? 4. It shows something. Whenever you have a simultaneous equation like this, it means that two of them is empty set. They are not inside this equation. But let's see what will happen. Let's use elimination method so we can finish up this part. Fast. So let me call here equation star and call here star star. So anywhere I'm mentioning star, you know what I'm talking about. Now I will say I want to multiply star times 4. That is this times 4. It will give us 4 into this will give me 12. 4 into this is 8 plus 1, 92c. Yeah, 92c1 because I'm multiplying everything by 4. If I times here again, I will have 92c2. 4 times 5 will give me 20. Now multiply C2, multiply star star by 23. We have the same thing, 92C1 plus 92C2 equals to 23. Now, if we subtract this, because we are trying in a way, so we are trying in such a way that we can eliminate either C1 or C2. So this is the elimination method. If we subtract, you will find out that if we subtract, we have 0 here and plus 0 here equals to minus 3. We have 0 here equals to minus 3. Now this shows that we can conclude here that C1, C2, C3 is empty. That is, it shows that there is no scalar C1, C2, C3. So this thing shows that C1, C2, C3 is empty. Since our C1 and C2 will delete themselves at once, and we have already put C3 in terms of C2 and in terms of C1 and C2. We have already put C3 inside them, and both of them deleted themselves, and we have minus 3. So C1, C2, C3 is empty. So there is no scalar in this that will produce what? This. Let's see the third example. The last question. It says find scalar C1, C2, C3 such that if C1 operates on this, C2 times this, C3 times this will give us 0, 0, 0. The same pattern. We move C1 times 1 is C1 plus, not plus, sorry, comma. We have C2 times 0, we have 0 here, plus 2C2, C2, because of the 1, 1, then plus 0, 3C3, and C3 will give us 0, 0, 0. Will give us 0, 0, 0. From there, we take them one after the other. C1 with this plus 2C2 plus 0 is equals to 0. We come back here. 2C1 plus C2 plus 3C3 is equals to 0. We take this again. The last one, 0 plus C2 plus C3 will give us 0. We name our equation. We have equation 1, equation 2, equation 3. I can start from equation 1, I can start from equation 3 to solve it. Let me start from equation 3. From this 3, we now have that C2 is equals to minus C3. We now say sub sub minus C3 for C2 in equation 2. Any place we see C2 here, we should put minus C3. So we come down here. We now have 2C1. So we are having C2 here. We put minus C3 plus 3C3 is equals to 0. We solve this. We now have 2C1 minus C3 plus 3C3 will give us plus 2C3 equals to 0. We call this equation 4. That is equation IV. Since we have solved this into equation 2, we are going to put this anywhere we see C2. Inside equation 1 again, we put this. So, we now say sub C2, sub minus C3 for C2 in equation 1. Now look at our equation 1, C1 and 2C2. So anywhere we see C2, we put minus C3. So we now have that C1 plus 2 open bracket minus C3 0, no need of putting 0, is equals to 0. We open this bracket, we now have that C1 plus, not plus again, 2 times this, will now give us minus 2C3 is equals to 0. So we can call this one equation 5. Now combining equation 5 and 4 together, since our C1 have no coefficient, so we have that C1 is equals to 2C3. This one crosses equal sign, changes to positive form. So we now say that sub 2C3 for C1 and 4. This means anywhere we see C1, we should put 2C3. So in this equation 4, we have 2C1, which will now be 2 open bracket 2C3 plus 2C3 equals to 0. 2 times 2 will now give us 4C3 plus 2C3 equals to 0. 4 plus 2 will give us 6C3 equals to 0. Divide both sides by 6. We now have that C3 is equals to 0. Now, since C3 is equals to 0, if we take this, C3 is equals to 0. If we take this C3 back to this our 5 and put 0 here, 2 times 0 is 0. You can see that C1 is equals to 0. If we take both of them back here, here is 0, 2 times 1 is 0. We put 0 here, 3 times 0 is 0. C2 is also 0. So since our C3 is 0 here, we conclude that C1 is equals to 0, C2 is equals to 0, C3 is equals to 0. So the only scalar that can multiply this 3 vector for the product to give us 0, 0, 0 will be 0, 0, 0. Watch it. If we put 0 here to multiply this, everything is 0. Multiply this by 0, everything is 0. Multiply this by 0, everything is 0. 0 plus 0 plus 0 gives you what? 0. And here is the end of the third example.